You guys, yeah. Do you guys know who that is? Oh, okay, great. Okay, thank you. Yeah. It's an old basketball player named Shaquille O'Neal. So he's like a towering 7-foot player. Yes, he is. Yeah. Why not? All right, guys. Go ahead. These are there's 3 questions for your warm up. Let me see how many you can solve. Find a space on the whiteboard and solve for it. Okay. That's gonna be your job. All right, Miss Tisa, come here. All right, and then your exam is gonna be on that table in the back, right there. There's a little chair there for you. Okay, Miss Tisa. Miss Tisa, what'd you do for Halloween?
I went to trick-or-treating with friends.
That's awesome. Yeah, I love that. I love hearing that. Good.
Yeah.
I probably win for the most boring
You gotta like tell people like, are you a little older? Like,
No, just give me the candy.
Yeah.
Just be quiet.
I win for most boring Halloween.
Oh, you went for most boring Halloween?
No, I win for most boring Halloween.
Why? What'd you do?
I didn't do anything.
Oh, really? Well, my girlfriend booted up Hocus Pocus, and I fell asleep at 7:00. So that was
Everyone in my house was gone, even my parents, so I got stuck with the dog.
Oh, that sounds really scary. Yeah. Yeah.
I had a mechanical pencil and it's like you guys have the same.
Oh, well,
everything about you is better.
Everything about myself is better.
Why is there a 4 next to the 2 and then like a bunch of equations?
Oh, sorry, that's not a 4. That's a quotation mark. That's, like the same. This is the same thing. Find the square root of, and then this says find the square root of. So that's what quotation marks usually mean, or not usually, but that's what they mean in this context. I'll freeze this.
Is that a Z or a 2?
That's a Z. That's a Z. That's a Z. Sorry. Yes.
Yeah.
That's how I ask you guys questions. Hey guys, why don't you 25? You should know what that means, right? No, I'm just kidding. No. What that means is this is exactly what it was above. So it's the same thing. Find the square root of, and this is find the square root of. Hey, Indigo, is your bag doing that?
Yeah.
That's really cool. Did you intentionally do that? Or? No. Look at it. Isn't that cool? Oh, shoot. Why are you carrying one? That's weird. Indigo, it looks like you're ready to just party anytime.
Yeah, 2 squared. What's 2 times 2? 2 times 2 is not 25. What? Yeah.
You will never know. No, it yeah, it just feels better on my back. Yeah, I guess.
So it's your bear desk.
It's my bear desk. Yeah, I guess so. Yeah. Wow, you guys are so quick at like, I don't know, making connections and stuff. I don't know. Yes, it's my bear desk.
It's our young minds.
Huh? Yeah.
It's our young sleep deprived minds.
A lot of the time you stay up late just contemplating life.
Kind of, yeah.
Really?
Also, you also stay up freaking out because your canvas hasn't worked for 3 days and you have no idea what to do for art. You also do that.
I just contemplate life a lot.
You always contemplate life. You'll sit there and just.
I have a lot of philosophical thoughts at night, and I forget them in the morning.
You always do that, and I feel honestly. This is the meaning of life. You have like an epiphany, and then you're like, wait, what?
It's like It's terrible. I got to play this tomorrow. But
Have you done any of your math?
Actually, I want.
I've done like one chapter. I've done one chapter.
Just shake it around.
Wait, it's under 1.5 chapter.
Yeah.
It's okay. You can be ashamed.
It just go ball moves.
Just guys, it's party time.
Yes. 9 times 10. 3 squared times 2 times 5.
Are you going to try to take the kids go back? Because I've got 20 bucks and the service. No, but by the end of the year, I need to save up. I need to take money out of the time.
All right, you guys ready to see the solutions? Check your answers. Okay, all right. I'll give you guys 2 more minutes to get what you guys can get done. Well, Indigo, what do you actually have that makes all those colors? Can I see it?
We need to keep it in the light so we know where to start.
Yeah, that's really whoa. You got a blingy one. That's so cool. Yeah, I like the shinies. That's cool. Okay. Here you guys go. Let's check your answer here. So you're supposed to factor out 80. I start with something really easy, 8 and 10, and then you just keep breaking down the factors. You guys get 4 root 5. Yes. All right. Good. You got 8. What?
I got that. You said get the square root.
Oh, did you? I don't even know which one yours is.
The black.
The black one? You got 8.4. Oh, okay. Wow. You went to town, didn't you? Okay. All right. That works. Let's see. Then the next one was a little trickier, but it was the same concept. You just break down all the factors. So I broke it down to 3xy squared z squared, and then in the root, I think I got let's see. I think I got 10 left in there. Am I missing something? I feel like 10 left, and then x and z. Anybody have problems with that one? It was a tough one. No. All right. What about the third one? Raise your hand if you did not know where to start with that. No, everyone knows how to do that one. Okay, so I really need a gauge to see, because this was actually, I think, 4-3, and these are like the first few sections. So I was like, I think they've already done this before, so I don't think I need to go over it, but I want to do it. So, yeah, you guys done this before? Okay. Did you? All right, so, all this is fairly new. All right. I guess before I start, anybody want to share what they did for Halloween?
I robbed strangers of their candy.
Did you? I have to report something like that. Oh, that's good. That's very responsible. Well, hold on, you're joking or not? I don't know. Okay, good. You seem like a really happy robber too. Give me the food. Give it to me, please. Okay.
What did you do for Halloween?
Me? I celebrated Halloween more on the weekend, I think, with my friends. Oh yeah, we did have a party at my house, but I will say this: I was the first one to fall asleep. I went to my room and I never came back out. So. Yeah.
I mean this kind of party, not the watching the movie kind of party.
Oh yeah, I mean we did. Yeah, we didn't.
How crazy!
We drank a lot of pop, a lot of soda pop. It was very fun. You guys know Hey Arnold?
Yes.
Yeah.
Oh, he's so funny.
I love your commentary. Oh, he's so funny. Yes. I went as Hey Arnold, and then my girlfriend went as Helga. What did you guys go as? Helga. That's the girl that's in love. I don't know. You can stay at home with your dog, just dressed up as. That's a funny image. Yeah.
Well, he looks like a leprechaun. That'd be kind of hard.
Wait, what else did anybody dress up at least? What did you dress up as?
Rosie the Riveter, I think I almost got offered drugs.
Oh, did you? Wow.
We were at a park and this pickup truck pulled up. When
Are
the
you
dads got out,
Oh, it's Halloween.
we thought there were gonna be like 3 guys in the front of the pickup truck. They park.
Uh-huh.
3 guys get out, and 2 just sit up in the back.
Oh, really?
Very slowly too.
Did you run? I
Yeah.
would have ran. Oh, you're very smart. Yeah, I totally would have run.
There were
Yeah,
a group of us, and we're all just like,
that just spells
"Let's get
trouble.
outta here."
Anybody else? Yeah, Sophia? As Wednesday?
Adams, right?
Oh, Wednesday Adams. Okay.
No, she dressed up as the day one.
What, Natalie? That brings me to you. Oh, what a great segue. Did you do anything for Halloween? No? Oh, okay. You didn't even dress up in your gi? Now that would have been, give me your candy, right? No, I'm just kidding. I'll break your brick face. I don't know.
Last year, it'd be funny if they had to come to your door and give you the candy.
Oh, that's a big shift. Yeah, I don't want to go to their house. They always take my candy. Hey, Indigo? You were Medusa. Oh, wow. Wait, that Medusa has one head. Yeah, but she has a snakes on her hair, or as her hair. Very cool. How did you do the snakes on your head?
Just attached pipe cleaners to the headband.
Oh, they say you touched type cleaners, and then you just grew in the street. That's awesome. Okay, cool. That sounds great. Anybody else before we start? One more. I'll take one more. Anybody else want to share what they did? Dash, did you? Or was that Katrina or Dash's hand? Katrina?
I don't think either of us did this.
No, I'm sorry. Yeah, I'm seeing things clearly. Yeah.
Are you okay? Just huge.
Yeah. Okay. Right. Oh. All right. Okay. Let's get to work then. Okay. So let's go ahead and write this down. These are your notes for today.
Are you sure it's 4.3?
Yes, I am. Yeah. I think. Yeah. Okay. It is 4-3.
That doesn't help my confidence.
I think I'm going to hopefully go through 3 sections, and I'm going to save the last section for next week, which is the beginning of proofs. Does anybody know what that means when I say proofs? Okay. You don't want to do proofs? Okay. We all will love proofs by the end of this. Okay? All right. Well.
I think that's it. Perfect.
Wait, what does it say after the 8?
Denominator.
Oh, yeah, sorry. Doesn't look like much. Okay, and then you're going to simplify this. So all this should be fairly familiar with some sprinkles and elements of new things, but today I think should go fast if we work fast, okay? And then next week we'll just be focused on one section because I think proofs is a pretty heavy topic. If you've never heard of proofs, I think that's where things get theoretical. For some people, it's like a paradigm shift. They never liked math up until this point, and then proofs just for some reason kind of click and
So
work.
if you liked math up until this point, you're probably going to hate it forever.
No, or it could add on to what you like too. It's just another dimension of math, another perspective of math. It's a paradigm shift. All right, guys. So what we're gonna do is we're gonna simplify. Yeah, Indigo. Huh?
Where were you yesterday?
I'll get back to that in a second. 1/2 2y. Okay, well let's see where we go with this first, and go to see if we achieve that answer. But the first thing that you're going to do for these type of problems is you're just going to distribute the square root sign to each individual numerator and denominator as such. So you essentially have the square root of 6y over the square root of 12. That is the same thing as if you just took the square root of the whole fraction 6y divided by 12. Okay? Now, there's a reason why I call it rationalizing. Does anybody know what that really means when I ask you to rationalize an expression? Make it rational? Why is this irrational? Why would this be considered an irrational statement? What do you think, Fayad?
Is it because it's not a whole number?
Not quite in this context. Petunia, do you want to? There's a radical on the bottom, so you can't have a radical on the bottom. So when they say rationalize something and simplify it, but more importantly, just rationalize it, you got to get rid of the radical. If you remember how to do that, you're supposed to just multiply it by itself. So that way, the square root of 12 times the square root of 12, you would just get 12. Yeah. But remember, you don't want to change the inherent value just by changing the bottom. You have to change the top too by the same value. So this is sort of like a giant 1. I'm drawing a 1 around it for about a few years, I don't think a lot of people really knew what that meant, so I never really explained it. It's a giant 1 covering the root 12 over root 12 because anything divided by itself is essentially just 1. So you're not really changing the value of this guy, okay? And then this will multiply, and then these guys are both the square root signs, so they'll both multiply underneath the square root sign. So you can multiply the 12 and the 6, that's 72, and the y still attached. And then the 12 and the 12 will just become a regular 12. Are we done yet, though? Is that the simplest form that this answer can take? No, we are not yet. Indigo, did you want to add to this?
No, I was just thinking.
Oh, okay. So let's factor this out into like I'll start you guys off with 8 and 9, I guess. And then how much further can we go with the 9? Like what factors go into 9? Like the simplest ones, yeah.
3 squared, which is just the outside.
Okay, so it's like 2 3s. What about 8? What are the simplest factors in 8? Yeah. 4 and 2. Actually, simpler than that. 2 times 2 times 2. So 8 breaks down to 2 times 2 times 2. And then just y. And then you pair up any roots like that or any repeating roots or pairs of roots. And then they will get pulled out. So we have a 3 and a 2. So that's going to be 3 times 2. And 2 and y stay in there. And then it's going to be over 12. And then you're going to have 3 times 2, which is 6. You're going to keep the root 2y as such. You're not going to change it. Or 12. And is that its simplest form? No. Okay, so what can we do now? I don't know. The little... Huh? What do you got?
You can get rid of 6 by doing making 12 2 and 6 1. 3 is half.
Okay, so yeah, you can kind of factor out 6 out of 6, and you can factor out 6 out of 12, right? You can factor out 6 out of 6 once, and you can factor out 6 out of 12 2 times. Okay, so that's root 12, or 2y over 2. That is your final answer. Okay, I'm going to give you one now, right? And then I'm going to give you a tougher problem. Yeah? Okay, cool. So let me grab the... Is it book?
That's exactly what I wanted.
That's what you wanted?
Yeah, tougher.
Oh, okay. Did you guys notice that I put in some... I didn't want that. Let me zoom out really quick. Okay. Anybody notice that on this month's homework, I gave you guys SAT level problems? How did you guys feel about those so far? What?
Yeah,
Easy?
they're
Really?
relatively easy.
Oh. All right. I didn't know. I thought if I put it on, I'm like, they're probably not going to like it, but I'm just going to give it to them. So we are required to give you guys more challenging problems. So, well, this form of math that we're teaching you is an older style of math. And it's still, I think, very foundational, but you have to do things with that math, right? That go beyond just the scope of just memorizing the square root of things and then adding things and then how you factor out things. You got to have an application towards it. I think the biggest thing lacking in today's work, it's not an opinion, statistically speaking from research, they're saying that people that get out of college are not quite innovative with what they've learned. They've learned things and they understand the ABCs, but they don't know what to do with the ABCs. So essentially, I've taught you guys the ABCs. Let's see what you guys can do with the ABCs when it comes to tougher real-world problems. Real world, okay? What are we on? Simplify. All right. Okay. Here we are. Try this one. On the board. Okay. We got that one, and then also find out the area for this guy. So go ahead and get on the board right now. I want you to find the area for this guy here.
Is the square root on the 15 as well, or just the 35?
What's up? Yeah, on both. On the whole thing. On the whole thing. I don't know about you guys, but I'd be pretty mad at this contractor right here. But he's going to build fencing with these parameters. 5 root 2 minus root 3 feet. This is a weird blueprint, and that's what he wrote in his blueprint. Okay, those are those dimensions. I want you to find the area of this space that he created. Okay, those are 2 separate questions. This is A and this is B. Okay, yes. Huh? Oh, whiteboard markers are now over there near Marla.
There.
There's your clue. I'll give you guys 5 minutes to do this. 5 minutes. You're still on number 1? Great. 4 more minutes then. No, I'm just kidding, Marvel. I'm kidding. Hassan, are you okay? You seem so quiet today, man. Yes, go ahead, please.
Okay, so it's a square. It's like we're doing the pattern thing. Okay, on the top.
Now don't worry about
Now I have to reduce this. Alright, so on the top, it's a square.
break it down to 2 factors that you know. I would use those 2 factors that we just did, 35 and 15.
That'd be a square root of 7.
Uh,
21 divided by 3 is
down there is 5 square root of 2.
It's fine. It's fine. I'm just kidding. Does that make sense? Yeah. Don't forget the denominator. 15.
Okay, wait. So it's good. Okay.
It's technically yeah.
Why are you giving you a hard time? Oh, I have your exam. Oh, so it's minus. Yes, you do have to include a minus. Where? Yes, yep. That is absolutely correct. I'll go over that one.
But that
9:46. What time do you guys get out? 10:35, right?
Divide 2.
Oh, let me turn on the lights.
okay, this is 4 times 26.
Hey, Lynn, you have a question?
They told me to come and take my test.
Yes, that's correct. So, what test was it? 8th grade science? Yeah. Alright, give me 1 second, guys.
What is 15 divided by 5?
Oh, wait, you're right. FOIL this?
Right. Turn them into the
Oh.
and then find an empty seat. So
This is
you're gonna have to work
Yeah,
alongside.
Beautiful children. Yeah.
There you go. Good luck. All right. I'm gonna come over to you guys. You just said my name.
Okay.
Then I'm gonna check your answer or check what you did.
Oh, wait, no, this is what we have to do. So 5 times negative 1.
You think so? You know
No, so it's just negative over yes. You see,
L.
that's way.
Yes.
It's just
Yeah, different style of cursive, sorry, so I can't read it. All right, guys, go ahead and have a seat. Let's have a seat. All right, and then Indigo, if you can, please turn off the lights. Or, you guys outside, thank you, Mara. We appreciate it. Okay, let's go through the first one. This was right out of the book. Okay, this was out of the book. Okay. It was phrased as a multiple choice problem. Which expression is equivalent to root 35 over 15? Oh, so is this technically wrong, or is this technically right? Yeah, it's technically right, but I guess they should have been a little bit more clear here. But in the simplest expression, please pick the simplest expression. Which one of these is the correct answer if you had to pick the simplest expression? What do you guys get? Oh,
A,
no.
B, C.
It's B.
B.
Is B? Yeah, what'd you guys get? Did you guys get root?
Divided by 3,
Technically
no?
B, but A and C are both correct too.
Let's see. Yeah.
If
Oh,
not,
okay.
going to
Yeah.
simplest.
Oh, okay. Yeah. I guess B, I guess, would be the simplest then, huh? Yeah. Because 5 over 15, do you guys get 5 over 15 at least to that step? Okay. That's actually very close. So I would say this is probably okay, that's just not right. That's good, but that's a little bit farther. That's a few steps back. So I think that's like one of the first few steps that you could do. Oh, look what they actually did here though. Huh. I don't know what they did here. What did they do? Oh, so here's a strategy. So in the book, yeah, actually you guys can do this instead. So you guys did the method that I taught you, okay? If you want, as long as the fraction underneath the square root sign, you can already reduce what's already there, 35 and 15. What's a common factor in 35 and 15, Indigo?
5.
So if you factor out 5 out of 35 and 15, you should get 7 over 3. And then from there, you just do the same thing. You have root 7 divided by root 3. And then at that point, you have to rationalize this by getting rid of the square root on the bottom. So you multiply it by square root of 3 on both the top, on the bottom and the top. And then at the very end, it just ends up being square root of 21 over 3. That's not a bad technique. Okay. Anybody get the last one? Let's see. No? Okay. All right. Yeah? All right. Yeah, maybe. No? oh, no. Oh, geez, no. Not so tall. I'm going to put up the answer. And then write this in your notes. So this is something that I want you guys to write in your notes. Yeah, most students can kind of guess that whatever I kind of go in class, that's pretty guaranteed that's going to be on the exam. Okay. Actually, what did you guys end up doing? How did you guys know? Okay, actually, it's multiplication. So, first off, the area of a rectangle is what? What is it? So in this case, you'd have to multiply the length times width, and the length and the width are both it'll come out as like a familiar looking binomial expression. So the first one is just 5 root 2 minus root 3, and then you multiply that by the other the length. I don't know. I consider it alongside the length and the shorter side the width. So just kind of get used to the way I kind of look at things. So when I say that, and then I took the length and I multiplied that. And then you guys could do FOIL if you guys are familiar with FOIL. That's like the first statement times the outside statement times I for in, and then last is these two. Or you can do it the way that I've been showing you guys. Just distribute this guy to both of these numbers and this guy to both of these numbers. Okay. So make sure you guys are writing this down. And then your final answer should be 5 root 10 plus 20 root 6 minus root 15 minus 12. What I said aloud, what did I miss when I said aloud to make this a correct answer? Katrina. Yes. So you can't just tell, like, if you say, how tall are you? I'm 77. Okay. What? All right. So I'm 77 inches, centimeters. Okay. That could be the difference between, wow, you're really tall, or wow, you're average. I don't know. 77 centimeters. I don't know how tall that is.
That's really below average. The average is like 130.
Oh, really? Okay. Yeah, for an adult. Are you calling me below? Yeah, that's actually really impressive that you know that. Is it? What is the unit in this case? Feet squared. Okay. So remember, the length is feet, and then the width is feet. So if you have feet times feet, that is squared. Okay. Why is it so useful to know that if it's squared, cube, or just feet?
Because it shows whether it's like, whether it's 2-dimensional or 3-dimensional.
Correct. Okay. So when you're talking about things in units, okay, you can either talk about it as flat sheets of paper, okay, or you can think of it in 3D space. You're talking about volume, all right, at that point. Okay. All right. Let us move on. Like I said, it's going to be pretty basic stuff today, relatively basic. And help me out here with how to solve this problem. So this is operations with radical expressions. Radical expressions. Then you're going to be adding and subtracting expressions with unlike radicals. Now remember, I don't want you to ever just passively write down stuff and then just be like, I don't know what he's saying. I'm just going to get an A on this thing, okay? What does unlike radicals mean? Or what do you think that means? Or what's a radical? What's a radical? There's two types of radical in my book. There's radical, and then there's radical. What's the other radical, though? Yeah, Indigo? So yeah, it's a square root. It's another way of saying a square root. But what do you mean by unlike square roots? How about, yeah, what do you think?
Different numbers.
That's it. That's it. It's unlike radicals, right? So what would that look like? And you're adding and subtracting them. Whoa. Okay. How are we going to do that? Here's an example of a question that you might see. You're going to be simplifying 2 root 18 plus 2 root 32 plus root 72. In this state, can I add these numbers together the way 72, right? Can I add these the way they are right now? Just smush them up together. Like, can I do it like this? The 2 and the T, I just like add together. That's 4. And in there is 18 plus 32. Yeah, that's like 4 root 50 right there. Oh, whoops, 50. Sorry. Is that possible? Could you do that? No. That's like saying, I guess, I don't know. You guys want to just see that why this doesn't work out, or no? Do we trust that it doesn't work out? Yeah. Yeah. You want to see it?
Yeah.
Okay, so let's try that. Let's just do this. 1 root 2 plus 1 root 3. In theory, I think I should add the ones together, right? 2. And then I add root 2 and root 3 together. That should give me 5, root 5, right? That's how I think it should be. Now in your calculator, someone grab out a calculator and add those together, okay? First, do this. Please do this first. Someone just calculate square root of 2 for me. That's it. I just want the square root of 2. Speak with confidence, like you did with robbing the children yesterday. Okay?
I wasn't robbing children. I was robbing the houses because they were giving me the
Oh, that's much better. So I'm glad you robbed the houses. I love your code of ethics there. Okay. Okay, go ahead. Yeah, 1 point.
1.412.
Okay, 1.41. That's it. Okay, how about root 3? Someone help me with 1 times root 3. Yes, Luciana. 1.73. Okay, so let's add these together roughly. What's 1.41 plus 1.73?
3 is actually 1.
Okay, 1.15?
No, 1.
Okay, in this case it's 1.4. Okay, wow, that's kind of close to pi. That's weird. Okay, now calculate 2 root 5. Yeah, 2 times root 5, or just 2 right next to a root 5, and that'll give you the same thing.
4.47.
Okay, are these two terms equivalent?
No.
Okay, so this equality statement is non-existent, and that should tell you what about this method of adding these roots together. It does not work. Okay, so this is simply not the way you do it. Right? So sometimes, other than just learning it, you might want to prove it to yourself, like, why doesn't the other way work? And then just try it, check on a calculator, and see, hey, it actually doesn't work. So mathematically speaking, that's probably not the right way to do things. The right way to do things. I feel like a Bugs Bunny trying to talk. Wait. Okay. Does anybody suppose what they know what to do to find the correct answer, though? Any suggestions? No? This is brand new territory? Yeah, what do you think,
I
Katrina?
don't know how to do it, but you have to make everybody in the row the same number.
Oh, like
To
the...
add the outside.
So you're saying the numbers underneath this umbrella, okay? Underneath these umbrellas, right?
Well, the ones on the 2 and 5. So you want to add the 2 together. The ones in the umbrella are the same.
Okay. Do you think it's limited to just the 2s, though?
No, you do the other one because technically there's 1 in front of it.
There's technically a 1 in front of it, okay? But remember, we can't add these together yet, right? The thing is, you need to make these roots like before you can start adding them together, right? So let's see. I think this is going to break down fairly nicely. Why don't we just reduce this as low as we can right now? Simplify this. This is not simplified, right? You can do this on your own paper if you want, but I know that this will break down to 9 and 2, these factors. I'm going to break down as simple as I can go. There's 2 3s that go into 9. I'm going to factor out the 3. And then this should now be 3 times 2 times root 2, right? Yes, sorry. 9 is 3 and 3. Am I missing something that you're saying? No? Okay. 2 root 32. What you want to do is you want to make this number under the umbrella, the final one, the exact same thing. Okay? So we're going to reduce this as far as we can go. That'll be 16 and 2. This would be 8 and 2. 4 and 2. Oh dear, this is a lot of 2s. I'm already getting tired. Okay, so I got 2, 2, 2, 2, 2. Wait, what? No, you silly goose, Mr. Wee. Wait, let's see. So what do I got? I think I'm doing something wrong here. Am I doing something wrong here? This is 4. Yeah, because that would mean the square root of 32 is what? 4? No, that's impossible. So I think I'm missing something here. Oh, I get it. Sorry. I'd erased this 2. So there's another 2 right here. Sorry, guys. Do you guys want me to redo this? No. Well, I'm gonna. Okay. No, don't you dare insinuate I'll mess this again. Okay.
Do 8 and 4.
I'll do what I want, Fayad. Okay. Thanks for the suggestion, though, Fayad. Okay. There we are. These. Okay. So I should have a 2 left in there. So this should reduce to 2 times, there's the original 2 times 2 times 2. And then you have in root 2. And then over here, is the square root of 72. I'm going to reduce that as far as I can. Be 9 and 8. That'll be 3 and 3. This will be 2 and 4. This will be 2 and 2. So that looks like it's going to be 3 times 2 times the square root of 2.
So they're all 6.
Well, what makes them all very similar, alike? They all have the square root of 2. In this case, okay, these are now considered like radicals or like terms because they all share a similar root. So it's like saying, another way of saying 6 times root 2 is I have 6 root 2s, right? Like pretend like there is a balloon with 6 of these root 2s flying around. Does that make sense? Yeah, that's a little balloon, right? Do not draw the balloon. That's a weird thing to have in your notes, okay? But it helps to understand this. And here, in this balloon, I have 8 root 2s. Does that make sense? Okay, 8 root 2s, right? There's 8 root 2s in this little balloon. And in this balloon, I have 6 root 2s. I have 6 root 2s, right? In total, if you add them together, how many root 2s do I have? Yeah, and then you can do that by just adding these numbers together. So, wait, 6, really? Okay, 6 times 6 is, 6 plus 6 is 12. Yes, that is 20 root 2. Okay? You guys are going to do this problem. You guys may do it with balloons if you guys would like. Okay?
On the board?
Do you want to do it on the board? Because you sound like you perked up a little bit when I said the board. Okay, go ahead. On the board. Go. This is your next problem. Go ahead and try this one out. Very good. What time is it right now? It's 10:05. We actually might get out early, guys, today.
Yay.
Yay! Good. Good for you, Mr. Reed. Good for you.
Yeah, it's also 4 times 6. It's not, it's different.
Oh, okay.
Yeah. 2 times 3 is minus 54.
Okay, Petunia, if you're finished with that, I'll give you one more, okay? Petunia has something under her breath. It's called fire. Okay. All right. 5 root 3 times 3 root 2 minus root 3. Oh, can you get this one? Can you get this one? Okay. So if you're finished with the one in blue, there's one more problem in green below it. That's correct. Hey, you ain't finished yet, children. There's one more question in Ren. Sorry. Yeah, I just added that. That's why. I'm going to walk around. If you need help, let me know. I'm going to help you out.
Is the next one under the next problem?
Yes, it is.
Oh, there's another.
Oh,
It's the same.
are we okay?
Okay, so
Ask me a question. You need
Okay, now we.
Okay,
this is 2.
Yeah.
1, 2. Oh wow, that's really good.
No, I wanted to
No,
one
2.
above. Like just one step.
Two,
Yeah, that's what it was.
And then
Wow, you really good actually. Very good.
so 2 minus 3 is -1.
No, because you have to, I don't know.
Yeah.
Another step.
Well, that is good. That is the answer I'm looking for. But the 2 will tell you you go one step further.
Isn't it? Factor out the 15.
Okay, that was.
Yeah, not 15. Yeah, that's what I was saying. So putting it, wouldn't it just be
Guys.
But mid 3.
No, I'm just kidding. Don't
Wait.
make your don't make your guys. It's good.
Is that good?
Here's my question.
Oh yeah, yeah. No. What would happen?
Why would I need to divide by 3?
You have to.
Why would I need to divide by 3?
Yes. 15.
Again, whole calculator is quick. If you're gonna divide this by 3, you get. I just want to see if these two are equal. If you're dividing by 3, is that what you're saying?
Yeah. No. But they're not. They're not.
They're not equal. Then why do you want to divide by 3?
I don't know. Because it's simplifying it.
But if they're simplifying, they have to do the same thing.
Yeah, well, then you did that and they're not. So.
Alright. I'll stick with my Thank you. There's one more problem, though, guys. So, yeah.
I spent all my room.
We have my
Wait, there's another?
I think I do.
Oh, wait. I thought that was just
You want to go?
Okay. Let's just do
Do you have
5.
another question?
Okay, let's just do 5. Let's and then do that time.
I do.
And then do Really?
I mean, don't quote me on this, but it'll be okay. I have that covered. But yeah, please keep cleaning. You know what they say? Research says is the best method. Soap. More than hydrogen peroxide. Just soap and water. It's surprising.
Or no, like do this times this separately.
So it's just really
Do
effective.
this times this
So
separately.
you're multiplying it. You're gonna multiply 5 by 3. The numbers equal.
Okay, so wait.
So I want to make sure.
What is this?
Here, and then it goes
Oh no, wait. This would be no.
Five times. Yeah. Right. Yeah.
I want to apologize in advance. Some
Yeah.
of my answers are I started in the middle of the box and
Yeah.
then I was like, oh, I need more room, so it kind of turns into a maze.
I don't worry about it. All right. Let's see what that means.
I love the exact same grade.
I don't have.
What did you get wrong? I want to see if you got the same stuff wrong.
Right. All right, guys. Have a seat. Have a seat.
Is this a 4?
It's a 1 over 4. Yeah.
I thought
Yeah. So you only missed a half, I think, on the first page.
Oh, I thought it was second.
Yes.
That's so late. What about you?
You had to get the.
I guess a -1.
Yeah. This is out of 2 points. So you didn't tell me what the vertex, the y-intercept, or the axis symmetry was. You did not tell me the domain range. You graphed it for me. That's great, but I wanted more. So you got 20.5 out of 22. It's an A. Don't worry. Yes. But so what you got to learn now is directions, my friend. Just read them.
Wait, this is incorrect. Wait, this one is. I just messed. I didn't write it right.
No, that's incorrect.
Oh.
Yeah. Yep. The rest is good, but that's incorrect. Okay. Have a seat for now. Okay. All right, guys. I'm gonna post up the answer really quick. So here's what you guys should have gone. You guys should have gone 3 root 6. If you need to write that down, then go ahead, all right? For the first problem. Nope. Was that you, Inigo? Nope. Okay. And then multiplying radicals, if you guys forget, you guys just do, what's that first step that we take to solve that problem that I gave you guys? It starts with a D and it is a property. Yes, Tessa. Okay, it is the distributive property. It's as simple as that. You just multiply the roots, whatever is beneath the root sign. So 3 and 2, that would give me root 6. And then you multiply the numbers on the outside of the roots. So 5 and 3, okay, that is 15. And then you do the same thing over here. You have 5 times 3 times 3. You should immediately see that's a pair of numbers. So you just pull that out of the square root sign. That's 5 times 3. 15 root 6 minus 15 is a perfectly good answer. You can take it one step further. How did you do that, Petunia, by taking it one step further? Yeah. Yeah, they both have a factor of 15. So if you wanted to, you could say that's 15 root 6 minus, you take out 15 out of 15, you're left with a factor of 1. So that is a perfectly good answer as well. Okay. We're down to our last problem here. Yeah, that's it. Well, yeah. No. What's that? Yeah. You don't trust my eyes, huh? Yeah. Yeah. We are. Okay. Why was I gone yesterday?
Yeah.
What do you mean? At what time did you come and see me?
It's a mystery.
Yeah, like that's why it's a mystery when we serve meat.
No, I left at like 2:30. So yeah.
But there were, you weren't there because I left.
Did you leave to get food at any point of time?
What do you mean? To get food?
To go get food.
Yeah, because I checked your room at like, I don't know, it was around like 12.
When she has class.
I was having lunch at that time, probably. Yeah, just eating. So I was in the mystery solved. Yes.
We're all detectives now.
Yes, I see. You guys are... And then I was also in the lab too as well.
Wait, what does that say?
Yeah.
T.
It's Tessa.
It looks like it says
Wait, what
It looks like it says
radical.
Radical equations. I'm sorry.
Wait, seriously, what is that for the T? Yeah, what's T?
Plus 5.
Oh, wait, you're right. It looks like test.
Man, I like this because you guys are on your toes and like now your brain's engaged in a weird way because.
It looks like my initials. My initials are TES.
Really?
Yeah.
Really?
Alright.
What is
Let me write this out even easier for you guys. I'm just kidding. No, it's not, guys. Come on, guys. I'm sorry.
T plus 5.
It's just as hard to read. God, okay. I am.
So give me one of those worksheets that
Wait,
says
yeah.
where you practice your handwriting.
We're gonna get you like the kindergarten ones where it's like Maserati.
This is real demeaning, guys. This is really demeaning.
Yeah, we'll get them from the
That
school.
equals.
When's your birthday?
Come on, guys.
When's your birthday?
Cut me some slack here. Man.
No, it'll be helpful.
Thank you.
For the students, not for you.
Yeah. No,
Yeah.
it's on both sides.
Then my students will understand better. I will write better.
Yes. That should be your New Year's goal.
That'll be funny. My girlfriend will be like, "What are you doing an hour a day?" I'm just learning how to write again. Gotta get back to the fundamentals, honey.
My students gave me all types of terms.
No, but honestly, I think if it was Halloween and you
Actually,
carry them,
as you guys write this
walk to
down,
the houses and, like,
write this off to the side. Try to solve this on your own. See if you can find out what T is. Don't worry about whiteboard. Just do it at your desk. But this is a good time to talk to your table mates. Like talk to people across from you and be like, what'd you guys get? Okay. So talk to everybody in your table to see what's going on. Except Alona, because you are taking a completely different test. Okay? Yeah. There you go. I like it. Yeah. That's how want you guys to learn. Yeah. Because you guys can't do this on the test, right? Hey, what did you do? Tell me.
No, honestly, Tessa was outside and I was taking my test and I was like,
Oh, really? You're all like,
I was
Give me the answers.
I forgot one of the formulas.
What do you do for this? Yeah, this is hard. How do you?
No,
solve-
for the test.
Oh.
But then it was pretty fast. Just like that group project you had to do month one.
I'll tell you this.
I thought it was
If you get your goal right here, your answer should be t is equal to -4 or -1.
I don't know where to start.
Yeah, none of us know where to start.
Give us like a clue. Yeah, I don't know where to
Give us a
Get
hint.
rid of that square root sign. I do not like that square root sign.
How do you get rid of
Give us a
You
hint.
multiply by
How do you
the-
get rid of square root?
Draw legs on it to go off. Yes, you can. And then you
I mean, mathematical legs. How do you get rid of the square root?
Would you square by a square?
What'd you say?
Multiply by a square?
You don't multiply by square, but you can square things. Yeah, okay.
So would you just square both sides?
They're only
Yeah?
squaring.
Yeah, there you go.
That's helpful.
You're only doing it so you can
I
take
got
out
it.
the
And then it's just what, t squared plus 9.
Fayad, what'd you find out?
I got t squared minus 5t minus 4 is equal to 0.
Back up. What'd you do? I don't understand what you did.
First, I squared both sides. And then you said it's wrong. And then
How do you get either?
t plus 5 is equal to t squared plus 6t plus 9, and then I
Wait. What? Wait. Back up. What? Fayad, slow your roll. Okay, go ahead.
get t plus 5 because you took out the square root and square.
Okay.
It's equal to t squared plus 6t plus 9
How'd you get that?
because it's like a plus b squared, and then you get a squared.
You really like that formula, don't you?
Yeah.
Okay. Well,
Wait,
t plus 3 on. T plus 3 squared. What is another way we can rewrite this
Yeah. A squared plus 2ab plus
without the formula?
t.
Wait. Marwa, I heard it in a way that's a little bit more digestible visually. Okay, so give me 1 second. Marwa, what do you have?
Plus 3 times 2 plus 3.
Okay, another way of saying it is t plus 3 times t plus 3.
Yeah,
Okay.
and then you do the answer though. Is that 3t plus 3t?
Okay, so then what are you saying to do now?
Oh, wait, I think.
Okay,
After that, you
on. I'm gonna give the floor to Lucian. I want everyone to contribute. Okay, so yeah,
wait.
fine.
So, if we're doing it with that method, wouldn't it be t squared plus 3t plus 9?
6t because
I mean 6t, yeah, 6t, not 3t.
Okay, so let me do the distributive property first. It's
Wait,
t.
oh,
We
yeah.
have t's, I need my t.
Wait, hold on. Go ahead.
We have to break it up like that. We can't put t squared plus 9.
Oh. You have to make sure that you multiply everything out. It's like, again, I'm gonna do it with.
It's the foil.
It's the FOIL method.
That's the FOIL method, but why do we have to break it up into 2?
Well, let's see. Okay. Oh, into 2 things here.
No, why do we have to make it t plus 3? Why can't we just leave it as t squared plus 3?
Oh, like this? Okay, let's do it like here. It'd be like 4 plus, let's see. Wait, hold on. Give me 1 sec here. Okay, it's like saying this. The way you're saying should be you square both the numbers in there, right? That'd be, so we know this, the actual answer is 4 plus 3. It's like 4 plus 3 times 4 plus 3, right? But the way you're saying is to do this. 4 squared plus 3 squared, right? Both sides should be equal. So let's see. Okay, let's see if both sides are equal. What's 4 times 4?
16.
And then what's 9? What's 3 times 3? Okay, so that's 25, right? Let's try this side now, okay? To see the side, the way that we know how we're supposed to do it, okay? So what's 4 plus 3 then?
7.
Okay, so 7 times 7 squared is 49. Is your way going to give me an equivalent answer to the actual way you're supposed to do it?
No, but like, why do we have to change it? I know it's gonna be different, but like, why? So you don't get it.
So that's what I'm trying to make the connection to. Because this here, t squared plus 9 is not equivalent to what this is actually
There were some equations
equal to.
that you would just do that, like the 4 squared plus 3 squared.
No, you never do that. The only time that happens if you have a difference of squares, you could take a shortcut. If you have t plus 3 times t minus 3,
Oh, that's what.
that's where you can take a shortcut. But you still have to make sure and verify when you distribute that that's going to happen, okay? So I could talk to you more about this, Katrina, okay? But let's just say that that method would not give you the correct value of what this is actually worth. T plus 3 times T plus 3 is not going to give me T squared plus 9, okay? Okay, so this is going to give me T squared plus 3T plus 3T plus 9. That's going to be T squared plus 6T plus 9.
But you forgot the T plus 5.
No, it's right there. Yeah. So don't worry about the scribbles and the side notes that I made, okay? Just focus on this part here. This is the only notes that we should be having in our notes right now, okay? Where do we go from here? So go ahead and talk with your people here, and then if you find something out, let me know what we can do next.
Okay. I think I see how you do it. Wouldn't you just do the, what do you mean? 60,
Thank you very much. This is your first time taking it, right? Okay, right. This isn't a retake.
Wait, maybe. No, but 6
What's that? Yes. Yes.
What will T plus 1? Yeah.
But this looks like the format for an equation like this. And there's T. That's what you're saying. But T plus 5, where does that fit with that?
Any suggestions so far about where we're supposed to go from here? This is not an easy question.
Factoring from like quadratic equation, like to do it that way.
You could, but you would have to set everything equal up to 0. You would have to set up.
Then how does the T plus 5 come into play?
Wait, so we're trying to find out what T is equal to?
Yes.
I don't do that.
Well, Luciana brought up a good suggestion. We could use the quadratic formula to solve for this, but we have to set everything equal to 0. How can we make this equal to 0? Okay, Tessa.
So you could do subtract T plus 5.
Yes.
Do it separately, so it's T squared minus, and then so it's T squared plus 5T plus
Minus 4.
Got it, because what you're going to do is you're going to subtract 5, right, Tessa?
Yes.
From this now. I just want to do it sequentially. So you have 0 is equal to T squared plus 5T plus 4. Does this seem like a problem that we can actually solve for now? If we solve for T. You have two options. You can either factor it out or you can use the quadratic formula. It's just instead of using X is equal to, we're looking for T. So it's the same concept. So what do you guys prefer to do? Would you guys want to do factoring out or would you guys want to do the quadratic formula? You want to factor out or
Yeah. Let's factor.
you want to factor out? Okay.
You don't seem too happy with that.
Yeah, because it's just I don't know if everybody's on the same page with factoring out.
Let's compact them up.
All right, let's do factoring out then. Okay, if we could factor it out, we could factor out to two numbers. That will give me A times C. My A and my C are going to be whatever's in front of the exponent squared, or the variable squared. That's 1 times C. That is 4. And then 5. Are there two numbers that can add up to, or multiply up to 4, but give me 5? That add up to 5. 1 and 4. Okay. Traditionally, the way that you're supposed to do it is, let's see, you write T squared plus 1T plus 4T plus 4, and then you group two numbers or two values together, or you make two pairs of numbers that have similar factors. I like these two because they both have T, and you have these two that have 4. So I'll write it like this: t squared plus t in parentheses plus 4t plus 4 in parentheses. You take out the factor, a similar factor out of t squared and t. I see that they're both that they have a factor of t in it, as confusing as that is. That's t plus 1 plus 4t and 4. What is a similar factor you could factor out of these two numbers? 4. That's t plus 1.
And then you can just do t plus 4
Uh-huh.
times t plus 1.
Very good. The t and the 4 have a similar factor of t.
And that's how you get the -1.
And then that is how we get the answer, okay, for t. So at this point, you set these two equal up to equal 0, okay? Yeah, it's not too bad. You should get t is equal to -4, and t is equal to -1. So the toughest thing, I think the two toughest parts about this problem is that you have to square root, and you have to get rid of the square root in the very beginning, and you have to get everything to one side. If you don't like this way, this is option 1. Option 2 is you can do the quadratic formula to solve this. There's one more option. Does anybody know what the third option is? Anybody know what the third option is? It's a device that you can use. What would you do in the calculator though?
You would just write t squared plus 5t plus 4, and then you would do second half, and then you would just find the left bound and the right bound. I think. Or each point.
I think you got the right answer, but your brain's just firing off a lot of information all at once right now, and your mouth can't handle the amount of information that's flooding to your mouth. But what you can do,
Or you could just go online and then type it in.
you could actually. So when you graph it, we don't have t, but you can always use the letter x. It'll be the same thing. X squared. Okay, give me one. Plus 5x plus 4. Remember, when we're setting it equal to 0, you're actually finding what the x-intercepts are. I don't like the way this looks, so I'm going to zoom out or standardize the zoom by hitting the number 6. And then I have two choices. I can either trace this, and find the x-intercepts, which is going to give me -1. The x value is -1, and the other one is whatever you're more comfortable with. Oh, okay. Oh, yes, that's fine. It's about -4. If you don't like that, that gives you a decimal answer. You could go really exact. You can go to 0, and then you can kind of set boundaries. Like you put a left boundary around this guy here. I think on new calculators, it sets the actual like a line straight down, and then you surround that x-intercept with another right boundary. So in between these 2 points should be where x is or y is equal to 0. You press enter, and then you get -4, and that is approximately 0. Okay, that's like a super small number. And then you do the same thing to the right side, right? For that. There's one more thing. I guess we couldn't get out early. I do apologize. There's one more thing I forgot to say. These are 2 answers. One of these is incorrect, though.
You can't just leave that out.
I can't. I just did.
You plug it back.
Wait, what? Say it again, Mr. Hibbett.
Put the numbers back.
Where? Where's the original equation? Oh. So let's go back. So you have 2 things. You have t is equal to -4 and t is equal to -1. Plug it back into this equation. Let's see. Okay, so we have 2 ways this can go. Let's plug in -4. This is sorry. Hold on. These arrows are very misleading. Okay, so we have we have t is equal to -4. Let's check to see if this is right. We plug it into the equation. -4 plus 5 is equal to -4 plus 3. -4 plus 5 is square root of +1 now. This is -4 plus 3. That is -1. And then technically this is plus or minus 1. That looks great if it was negative, okay? Like -1 is equal to -1, but what about the +1?
So then it's 10.
Yeah, this is not true. This is false.
So then the -4 is false.
So let's try this one here. This scenario is where t is equal to -1. And let's plug it back into the original equation. That is t plus 5. Or sorry, that's -1. We'll say that's -1 plus 5. Sorry, is equal to -1 plus 3. And I guess, let's see, -1 plus 5, that is the square root of 4. -1 plus 3, that's 2. Oh, actually, you know what? I don't think in the book they specify this. That's pretty bad, actually. They just say this. I think in the book they just say, that's +1, this is +2. So this is true. And over here, this should be false. So I guess they don't want you to do the plus or minus, which is kind of odd. Yeah, okay. So I guess you just say the square root of 4 is positive and the square root of 1 is positive. Okay, I don't really like that too much, but that's what your book's kind of teaching you right now. Huh? That's definitely going on the test. Oh, I got you. Okay, all right. I won't. I'll just go by the book and just go by what the book's teaching you guys. All right, guys. Put away your chairs, go home, and you guys have a great day, great weekend. I'm sorry Halloween is over, though. So